Hello friends, here is Mr. Ramesh Chandra, BTech from IIT Kanpur and taking second lecture on the topic probability. In the previous lecture, we learned about the historical part of the topic, its various application in daily life and the importance of the topic in various competitive exams. Here we have some pictures. You can see image. We are having a image of tossing a coin, and second one you can see this one. We are rolling two dice, and this image we are having some card and a dice over it. The more of the competitive exam problem are based on these coin, dice, card and dice. It's depend on the examiner mind. And we have two more pictures over here. First one is the book Permutation and Combination, and second one Mathematics, the first step. These are the books that I have authored, and these books are available at Amgen, Flipkart and Mathsarc Education. So let us start with the definition part. Many mathematicians define the probability, and one of them is probability is a measure of uncertainty of various phenomena. See, if we toss a coin, the probability of getting head. You can more talk about the uncertainty principle of Huygens, production of electron, and even you can think of probability distribution in chemistry as well. So what probability is? Probability is a measure of uncertainty of various phenomena. We have sub part. First one is the basic unit that we have, or basic terminology for probability is, first we have is random experiment. So what is random experiment? It is an action in which all the possible result of action are known in advance and the exact result is unpredictable when experiment performed. Means ये एक एक्शन है जिसमें कि हमें सारे रिजल्ट पहले से ही पता होते हैं कि ऐसा होने वाला है, पर एग्जैक्ट रिजल्ट क्या दिखने वाला है ये हमें नहीं पता होता है. सो इस तरह की एक्शन को हम रैंडम एक्सपेरिमेंट बोलते हैं. यू कैन सी अ random experiment is an action in which first all the possible results of the action are known in advance, and second condition that we have is the exact result is unpredictable when experiment performed. Throwing a coin is a random experiment. Second one, we can have example number 2, drawing a card from deck. Is a random experiment. So you can see throwing a coin is a random experiment. Drawing a card from deck is another random experiment. Now let us move on the next sub definition, that is outcomes and sample space. Another terminology that we need to understand before learning probability. So what is an outcome? outcomes. What is it? A possible result of a random experiment is called its outcomes. Means यदि हमने कोई एक्सपेरिमेंट परफॉर्म किया तो उसके जो भी पॉसिबल रिजल्ट्स हैं वो सारे के सारे आउटकम्स होते हैं. Like, let's have the definition. A possible result of a random experiment is called outcomes, is called its outcomes. Let's have an example. If we roll a die, then possible outcomes are, if we roll a die, then possible outcomes are 1, 2, 3, 4, 5 and 6. So each one is an outcome. 3 is an outcome. 5 is also an outcome. Let us move on another example. Example number 2. If we toss a coin, then possible outcomes are head and tail. So both are the possible outcome if we perform a random experiment, that is tossing a coin. Random experiment, watch. Tossing a coin, in which we have outcomes head and tail. Now let's say we have another example. Example number 3. Let us talk about the experiment part. Experiment. Suppose a random experiment is arrangement of letters A, B and C. So what is an experiment? What is an experiment? Experiment is the arrange A, B and C in a row. Experiment is arrange A, B and C in a row. This is an experiment. This will go under experiment. And what about the outcomes? Outcomes. What are the outcomes? Now if we think of arrangement of letter ABC, then possible outcomes are, you can have A, B, C, B, C, A, C, A, B, or A, C, B, C, B, A, B, A, C. So these are the possible outcomes if we arrange ABC in a row. So in this case, we have 6 possible outcomes. ABC arrangement is an experiment and their outcomes are 1. This one is one outcome. This one is another outcome and so on. Next we have another terminology, equally likely outcomes. What is equally likely outcomes? Let us learn about this. For this we have experiment. First experiment number 1. Toss 2 coins of different size. Let's say one is a small one and another coin is little bit bigger. So what are the possible outcomes in this case? Head, 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 tail, tail, head, tail, tail. So we have these 4 possible outcomes in this experiment. Now let us think of another experiment. Now in this case, experiment number 2, toss 2 coins. Toss 2 coins of same size, or we can say this, toss 2 identical coins. What are the possible outcomes in this case? You can see, let's say these are the 2 coins, 2 identical coins. So possible outcomes, you can head, 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 tail, and tail, tail. Do we have tail, head as outcome? No. Why no? Since the coins are identical, so we will be unable to distinguish these 2 cases. You may have some feeling that here we are having 4 outcomes of the experiment number 1, and in this case experiment number 2 we have only these 3 as outcomes. So chances of occurrence of each, in this case experiment number 1, each outcome is equally likely, but in this case the outcomes are not equally likely. Outcomes are not equally likely. The sample space. What is sample space? Sample space, the set of all possible outcome of an experiment is said to be the sample space of the experiment. What does it mean? कि कोई भी एक्सपेरिमेंट यदि आपने परफॉर्म, तो उसके जितने भी पॉसिबल आउटकम्स का कलेक्शन एक सैंपल स्पेस होता है. जैसे यदि मैंने एक डाइस को रोल किया तो क्या क्या पॉसिबल आउटकम्स आ सकते हैं? 1 2 3 4 5 6, and that is sample space. Yes, we denoted sample space by capital S. यदि हमने 2 कॉइन को टॉस किया, if we throw 2 coins, then sample space is the collection of all the outcomes. So let's say this time we are having 2 different coin. We need to assume 2 different coin unless the examiner haven't tell about the identical nature of. So let's have 2 different coin, then possible outcomes are head tail, tail head, tail tail, and head head. So this is the sample space if we throw 2 coins simultaneously. Let us have another example, that is, consider an experiment of shooting a tiger until there is a hit. Example, let's say, consider the experiment of shooting a tiger until there is a hit. Now, what kind of sample space it is? Let's say S is denoting the sample space. Consider the experiment of shooting a tiger until there is a hit. So if we shoot first time, then if there is hit, then we need to stop. If there is miss, then we need to apply again. We need to again shoot on the tiger. And if this one is a hit, then we need to stop. Similarly, miss, hit, miss, hit, and it will go infinitely. So for this sample space, infinite numbers of sample points. Even for this outcome, we also call this as sample points. Sample points. We toss a coin, then there was head and tail. So head and tail are outcome. We also says that this is a sample point, or even sometimes we say simple point as well. So let us move on the question part. This was the theory. First one is the experiment, random experiment. What is random experiment? This is an action in which all the possible result of action are known in advance. An exact result in performing the experiment is unpredictable. And second one, we have outcome and sample space. Outcomes is the possible results of an random experiment, and sample space is the collection of all the sample point or collection of all the outcomes. So let's move on the question part so that we can have crystal clear theory. So let's move on question number 1. Solve this question here on. In each of the following experiment, in each of the following experiment, specify appropriate sample space. First one is, from a pack of card, one card of heart is drawn. One card of heart is drawn. Second one, a boy has a 1 rupee coin, a 2 rupee coin, and a 5 rupee coin in his pocket. He takes out of his pocket one after the other. And third question we have here, a positive integer is selected. Positive integer is selected at random and is divided by 7, then outcomes outcomes are reminders. Reminder. So we have these three examples, three questions you can say. In each of the following experiment, specify appropriate sample space. From a pack of cards, one card of heart is drawn. So in a pack of cards, there are four type of card. One is heart, second one is diamond, third one club, and last one is spade. And these two are of black colors. These two are of black colors, and these two are of red color. So from a pack of card, one card of heart is drawn. It may be ace, A, then this 2, 3, 4, 5, 6, 7, 8, 9, 10. Then we have J, Q, and K. So these are the possible outcomes if we draw a card, one card of heart is drawn. So these are the possible outcomes, and hence we have sample space as shown here. Now in example number 2, a boy has a 1 rupee coin, a 2 rupee coin, and a 5 rupee coin in his pocket. He takes out his pocket one after the other. What he is doing? He is removing coin one after the other. So what may be the sample space? For example number 2, we have sample space as, if he draw first coin, then first coin may be 1 and second may be 2, then 1 and then 5. Then we have, first he can take out 2, then he take out 1, then second one 2, then 5, first 5, then 1, and then 5 and 2. So these are the possible outcome. You may think of like 1 2 1 5 2 5. Thinking of this sample space, then this is wrong. Why it is so? Since in this case order is important. He takes out of his pocket one after the other. One after the other. This is an important line. So in this case we need to have order. In this case we are not having order. So this one is the correct sample space. And the last one, a positive integer is selected at random and is divided by 7, then outcomes as a remainder. Then any integer may be of type 7k, 7k plus 1, 7k plus 2, 7k plus 3, 7k plus 4, 7k plus 5, and 7k plus 6. So possible remainders are 0, 1, 2, 3, 4, 5, and 6. So in this case we have sample space as shown here. 0, 1, 2, 3, 4, 5, and 6. Now let us move on the another question. We can have next question number 2. A box contains 1 1 red and 3 identical white walls. 2 walls are drawn at random. 2 walls are drawn at random in succession without replacement. First off, write the sample space for this experiment. Write the sample space for this experiment. So think about the solution. So what should be the solution? A box contains 1 red, 3 identical white ball. 2 walls are drawn at random in succession without replacement. Write the sample space for the experiment. I am writing here my sample space. You can write yours. So here we have, first we can have red and then white. Second one, in the first case we have white and then red, and in another case we also have white and white. You can see, you can have feeling of sample space which are not equally likely. Sample point are not equally likely in this case. They are not equally likely. Now let us move on next example or next question. Question number 3. A coin is tossed. Coin is tossed if the outcome is a head. A die is thrown. If the die shows up an even number, the die is thrown again. Die is thrown write the sample space for this experiment. The sample space for this experiment. A coin is tossed. If the outcome is a head, a die is thrown. If die shows up an even number, the die is thrown again, and then we stop the experiment. So write the sample space for this experiment. Before watching my answer, just write your own so that you can understand whether you are correct or not. So we are having solution for this question is sample space. A coin is tossed. If outcome is head, a die is thrown again. So let's say we have tail as outcome. So there is no experiment and if tail is shown. Now if head is there, then we need to throw a die. and that then die will show number as 1 2 3 4 5 6. Then again, if die shows an even number, the die is thrown again. So if we have odd number here, head 1, then we need to throw die again. Head 3, head 5, then we need to throw die again. Now if we have head and 2, then we need to die throw again, then that is 1, head 2, head 2, 2, head 2, 3, head 2, 4, head 2, 5, head 2, 6. Then similarly we have head 4, 1, head 4, 2, 2, head 4, 3, head 4, 4, head 4, 5, head 4, 6. Similarly we have head 6, 1, head 6, 2, head 6, 3, head 6, 4, head 6, 5, head 6, 6. So you can see that these are the sample point in this experiment. If we talk about the number of element in sample space, for this case particular, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22, you can see. Or even you can see there are 3 even number, and corresponding to that we have 6, so there are 18, and 3 cases also there, 18 3 21, 22 and 23. This is 22, we already counted this, so we have 22, NSS 22. Now we have question number 4. A coin is tossed. A coin is tossed. If it shows a tail, we draw a ball from box. We draw a ball from a box. Box contains 2 red and 3 black balls. If it shows head, we throw a die. Find the sample space for this experiment. Find the sample space for this experiment. Read it again. A coin is tossed. If it shows a tail, we draw a ball from a box containing 2 red and 3 black balls. If it shows head, we throw a die and find the sample space for this experiment. For this we can have solution as, you can write your own solution so that you can match whether you understand sample space correctly or not. So here we have sample space as, a coin is tossed. If it shows tail, we draw a ball from box. Let's say if it is showing tail, then we draw a ball from box. Then what should be the sample point? Tail, red 1, tail, red 2. Why red 1, red 2. Since there is nothing is given in this question that red balls are identical or not, so we need to assume these two balls are different. So tail red 1, red 2, then tail black 1, tail black 2, tail black 3, third ball. Now if there is head, we throw a die, then head 1, head 2, head 3, head 4, head 5, head 6. So these are the possible outcomes, and their collection is the sample space. Thanks. In the next lecture we will work on the event and more. I hope you get the concept of equally likely, sample space, outcomes, and the definition of probability.